Hello everyone. I noticed that there are many videos available on printing a 3D vertical aeroponics tower, but not much on how to set it up, what plants to grow, where to place them in the tower, nutrient levels, and basically how to grow plants successfully. This video is meant to fill that gap. It will include all I just said along with pump sizing, timer setting, media options for the net cups, and as a bonus I've embedded in the video my spreadsheets that have over 60 types of plants with pH levels, nutrient density ranges, growing seasons, and plant spacing in vertical grow towers. I'm using a tower that I created on my 3D printer from a previous video. Welcome to Expat Hydroponics. In my last video, I described creating a 3D printed vertical aeroponics tower. I will use part of that tower for this video. This tower was printed from PLA plastic, so it's not ideal for an outside growing environment. However, it is what I have, and I'm sure to last at least one growing season. First of all, for this build, I needed a nutrient tank that will double as the base for the tower. I selected a 5-gallon bucket from the local big box hardware store. I purchased a snap-on lid that should help with the stability of the tower. This tower comes with an adapter that connects to the lid of the nutrient tank bucket. First, I traced a hole that was slightly larger and cut it out with a small saw, although I'm sure that I could have also used a box cutter. Next are the 3 holes to attach the adapter. I used 1/4 1-inch stainless steel machine screws with a nylon lock nut. These were slightly too large for the existing adapter holes, so I used a drill to drill out the adapter and the lid. The first section of the tower is the filler module. It has a convenient spout for topping the tank with water and nutrient solution and pH adjustment additive as needed. Also, there are slots in the side for the cord that connects to the pump. Before I go on, I need to do a little planning. I need to decide on what plants I want to grow and how many. To save some time, I purchased some herbs and vegetable plants when I was buying the screws at the hardware store. I will also add lettuce later. Lettuce is a fast grower that normally matures from seed in about 6 weeks in an aeroponic system. Here's what I have: 2 Italian and 1 regular cilantro plant and 1 jalapeno. These are the main ingredients to Peruvian green sauce, which is my favorite. 1 large beef tomato, 1 rosemary, 1 eggplant, 1 zucchini, and 1 cucumber. All these plants look a little sad, and I hope they perk up once in the tower. I will leave room for 3 lettuce plants to be added later. This makes 12 plants and means 4 3-hole modules. I'm pretty sure that all these plants don't have the same pH and nutrient density profiles, but I'm already building a second tower so I can group plants together and later I can move them around. Let's take a look at the plant profiles. Cilantro likes full sun. It is normally a cool weather plant. However, Italian cilantro grows better in warm weather like the Mediterranean, so it should do fine in Texas. It should be placed in the upper sections of the tower, requires a pH of 5.8 to 6.4, and a nutrient density of 600 to 800 ppm. Next are the peppers. Jalapeno likes full sun, a pH of 5.8 to 6.1, and 1750 to 2000 ppm nutrient density. Also should be in the bottom or middle with supports later for the fruit. Bell peppers are the same with a pH of 6.0 to 6.5 and a ppm of 1400 to 2000 nutrient density. Cucumber, tomato, and zucchini are all shown here, all warm season and vining, with heavy fruit that requires the bottom of the tower, with supports for the vines to be added later. Also similar pH and ppm profiles. Eggplant can be located on the bottom or middle with a ppm nutrient density of range of 1750 to 2450. Rosemary is the last, and it's a cool weather plant, so it may not survive here in Texas. This should go on the top or middle of the tower. Here's the layout plan. A target pH of 6.0 fits into all the plant ranges. Nutrient density of 1600 is actually too much for cilantro, rosemary, and lettuce, and a little light for the eggplant. However, this should be okay until I build a second vertical tower. On to the build. I have an old pump that I plan to use. It has a lift rating of 4.75 feet, which should be enough for this tower. Since the pump was old, I tested the lift based on the 1/2-inch ID flexible tubing and discovered that it would not lift the water as high as I needed. I removed a few of the spacers and reduced the height of my tower to around 4 feet. This seemed to work. Something to keep in mind is that in my experience, these pumps nearly always fall short of the rating, even when you purchase them brand new. Also, the lift and the liters per hour will be reduced the smaller tube or pipe you use to connect to the dispenser. It's better if you buy a pump that is stronger than what you actually think you need. It is important that the tower is vertical so water is evenly dispensed to all net cups. I use baling wire to accomplish this by connecting the tower to the post on my deck. The lid to my bucket was not strong enough to keep the tower vertical. Also, it gets a little windy near my home, so this will keep the tower from toppling over. The common media for net cups is either clay balls, also called hydroton, or coconut fiber. For this build, I'm trying out sphagnum moss. Sphagnum moss tends to be a little acidic, but that may help me as I need to lower the pH of my tap water. A tip I learned is to wrap the pump in a paint strainer. This prevents media from clogging the pump. Next is to add nutrients. I have a little less than 5 gallons and I use Masterblend hydroponic nutrients. I'll post a link to MHPGardener to his video. Even Masterblend refers to this YouTuber as a reference. According to him, I should use 12 grams of Masterblend, 12 grams of calcium nitrate, and 6 grams of magnesium sulfate per 5 gallons of water for tomatoes. I will double that and mix into 1 liter bottles for my A and B solutions, and then add 500 milliliters of each to my bucket. I can then adjust up as needed to get to my target level of 1600 ppm. I have a feeling that this will be too much for my cilantro, but let's see how it goes. If you need more information on mixing nutrients, I have a more detailed video linked here. When adding the plants, make sure you remove all the potting mix from the roots. It's better instead if you plant ahead and grow from seed. I'm concerned that these plants will suffer shock from the transplanting process. You can see that I did not follow my plan exactly in the case of plant placement. I'll transfer these plants later into different vertical grow towers in order to group them better by pH and nutrient ranges. I purchased a cheap timer from the hardware store for about $6. Timer settings vary quite a bit depending on who you ask. The key is to not let the roots dry out, but also allow them to get oxygen. It has been between 90 and 100 degrees here in Texas over the last week, so I'm running my system 30 minutes on and 30 minutes off, 24/7. As a comparison, my brother in California left his off all night with no issues. The roots of plants like strawberries and tomatoes need more aeration, so depending on your weather, you'll have to take that into consideration. The last thing I'll mention is testing. I purchased a handheld meter that tests both pH and TDS, total dissolved solids measured as ppm, parts per million. As your plants grow, they'll use up the nutrients in the water, and you'll need to add your A and B solutions periodically to bring the ppm back into your target range. The same goes for pH. It's best if you buy pH up and down online for this purpose. However, some use alternatives like citric acid. The pH is important as plants cannot easily absorb certain nutrients unless they're in the correct pH range. I think that covers all that I promised. Congratulations, you made it to the end of the video. Here are the charts I promised. Just pause and take screenshots. Don't forget to help me by liking and subscribing. God bless.